different theorems and corollaries and postulates that there are in relation to a triangle. We use them in proofs. Okay, so we use them when we deal with circles, and quadrilaterals. So every time we deal with something new, we end up relating it to a triangle in some way. It seems like so. Making sure that there's a good understanding you guys are asking questions today is helpful. So the first thing to do, study those theorems and that corollary, and draw a picture to describe a remote, the exterior. If it helps you, you could draw a picture for the theorems and corollaries. That may be helpful. It's not necessarily something that's essential, but you at least have read over them. Some of you know, and some of you will be like, oh, okay, I knew that. I just didn't know I knew that. All right, so go ahead and get a book now. Work on that. Okay, here we go. So triangles. Let's talk about these theorems here. Theorem 2-1. Got them right here for us. Theorem 2-1. Triangle angle sum theorem. Now you'll notice this one says Theorem 2-1, but then it actually has a name for it, the triangle angle sum theorem. That's the common name that everyone recognizes this theorem as. The triangle angle sum theorem just says all angles of a triangle add up to 90, or add up to 180. They're supplementary there. Add up to 180. Now how many of you already knew that? Okay. How many could prove that? All right, we'll go to that here in a minute. Exterior angle theorem says the measure of each exterior angle of a triangle equals the sum of the measure of the two remote interior angles. In other words, it says that this angle plus that angle equals that angle. Okay, angle 2 plus angle 3 has to add up to angle 1. Okay, because this one plus this one, along with this guy right here, adds up to what? 180. And what does 1 and this guy add up to? 180. They make a straight line, right? So if this plus, let's call this angle A, add up to 180, and 2 plus 3 plus A add up to 180. Everyone follow me so far? Well, I guess, does everyone agree with that? 2 plus 3 plus A add up to 180? Yeah, that's what this said, right? Triangle angle sum theorem. Okay. And we also know that 1 plus A have to add up to 180. Tell your neighbor why these two add up to 180. Okay. So we know that 1 plus A equals 180. And that's because a straight line is 180 degrees. So that means if this plus A add up to 180 and this plus A have to add up to 180, that means these two have to be the same. Everyone see that? Based on substitution, these two pieces must be the same if everything else is the same. So 1 and those two have to be equal. And we'll show that here with a picture here in a minute as well. A little piece. So last one, corollary to theorem 2-2. So an added piece to this theorem. A corollary is like an attachment there. Angle 1 is greater than angle 2, and angle 1 has to be bigger than angle 3. They're just saying, you know, if these two have to add up to that, then this has to be bigger than that one, and it has to be bigger than that one. That's kind of one of those, well, yeah, duh. Yeah. I mean, of course, that's true. All right? If this one equals those two together, then this one's bigger than that, and that one's bigger than that. Okay. Any questions on those? Let me take a triangle here. Got our triangle. Okay? And I'm going to tear off all three angles of that triangle. I know it's kind of sad. Poor thing, I know. Okay? And just so you know, I know, it's like someone got hungry.
Just ate the angles.
Poor thing. I know. Well, if it's true that angle A plus B plus C add up to 180, then that means I should be able to piece these together and form a what? Yeah, a straight line. Question is, can I do that? Hi. We're just dealing with people eating triangles here. Okay. I don't know. It's tough to move that piece. Dude. That's pretty darn close, huh? Yeah, check it. That's because I can't get this one. I feel like a surgeon right now, dude. This is what it's like. Maybe a little more intense. Hey, there's my straight line, right? Cool. How many are with that? Yeah. Okay. Hey, one other picture that could help out is seeing something like this. Really what's happening, similar deal. If I were to tear off, say, angle 2 and angle 3 and attach them to a line coming off this angle right here, which we just called A in another picture, then these two would match up and fit perfectly right here. Okay? It's helpful to be able to see the pictures to sometimes summarize what we have. Okay. Any questions there? I want you to tell your neighbor all the different types of triangle, all the names and all the different types of labels you've ever heard for a triangle. Okay? Write them down. Just write a quick list on scratch paper while you're talking about it. All right, so a bunch of us have a list. Let's see. How many of you have those different things? How many have equilateral? Who has equiangular on their list? Yeah, equiangular is not one we get too often. How about acute? How many put acute? Oh, okay. How many put isosceles? How many put right? Hey, that's right. How many put scalene? How many put obtuse? How many put something else? A triangle, triangle. Wow. Chase, what do you think? Never mind triangle, all right. What did you guys get?
Yeah.
Okay, well, let's talk about these. What does equiangular mean? And I know most of us didn't put it, but what do you think it means? Emily? Yeah, measure of the angles are all equal. That's equiangular. Measure of the angles are all congruent. Now, the reality is, if something is equiangular, that shows equiangular right there, all angles are congruent, then it also means it's equilateral, meaning all sides are congruent. For a triangle, okay, that's in a triangle. It's not the case for all shapes. Like a quadrilateral, you can have 4 right angles, but not all 4 sides being the same, right? Like a non-spherical, which isn't a word, rectangle. Yes?
Is that the only situation that equiangular could be present?
For a triangle, yeah. If it's equiangular, then it's equilateral in a triangle. Okay? Right. So we've got our markings, right? What's acute? Blake, what do you got for acute?
Acute is it's a triangle that is an angle of less than 90 degrees.
Good, less than 90. It's little. Oh, it's cute, right? Less than 90 degrees. Okay, and only has to have one acute angle. Or excuse me, it has to have all acute angles. I'm sorry, I'm thinking obtuse. Obtuse, let's go to that one real quick. Go ahead.
Well, no, I have a question about the acute one.
Oh, yeah.
That's when all the angles add up to less than 90.
No, all angles can't add up to less than 90, right? All angles are less than 90. So each angle is less than 90, if you want to think of it that way. That's probably a better way to say it. Each angle is less than 90. Your angles still add up to 180, otherwise you don't have a triangle, right? What's obtuse mean? Skip right for a minute. Carson?
One angle more than 90 degrees.
Is he right? One angle greater than 90? Could you have more than one? Sorry, you can't see that. Can you have more than one angle greater than 90?
I don't think so. Because it would
Tell your neighbor, why is that not possible?
Because it would be able to add up to 180. It'd be like 2 huge numbers. And then it'd be like one, like the one, like 1 degree angle. It'd be like just right.
Okay, Miss Holly, you know? Go for it.
The reason why you can't is because if you have a 90-degree angle, if you have more than 90-degree angle, if you try to make it more than 90-degree angle, you end up having more. You end up having four sides.
Yeah, if you had more than one right angle, you couldn't make a triangle out of it, right? I mean, think about it. Like Maggie's saying there, if you have a right angle, and then you have another right angle, well, you'd have to have another side to make it work out. Otherwise, they won't hit. Right? Now, the only time that this is possible is in what's called spherical geometry. When we do spherical geometry, we touch on that a little later in the year. When geometry on a sphere, you can actually have a triangle with 4 right angles. Or 3 right angles, excuse me. Okay? So that's a bit different, but we're not dealing with that right now. So, right triangle means we have how many right angles? 1 right angle. 1 right angle. Okay? All right. Isosceles. Isosceles? Yes.
Turn all the, or 2 of the sides are equal.
Yes. At least 2 sides equal. At least 2 sides congruent. It's not only, it's at least. So equilateral is still isosceles. Right? It's like a square is still a rectangle. It's just not every rectangle is a square. Oh, thank you for pointing that out. Isosceles. A square is a rectangle, but not every rectangle is a square. Isosceles triangles, well, every equilateral triangle is an isosceles triangle, but not every isosceles triangle is equilateral. It's the same idea. Okay, so you have to have at least 2 congruent sides for isosceles. What is scalene, Carson?
No sides congruent.
No sides congruent. And so if I had no sides congruent, Cameron, do you know how that is one of the worst triangles ever. Unbelievable. Here, let me fix that. That's what I get for looking away from me. Gee, man, Chris. Hey, Mr. Colstead, I thought I got rid of you in high school. Okay, there we go. Cameron, do you know how I'd make those markings?
Like for the line?
Yeah, so like, if I said that's 1 mark, what would I put here? 2, and here? 3. Very good. A scalene, you want to mark it as a scalene. Mark it, all 3 sides are different. That's scalene. Okay? So we classify triangles really in 2 different ways. We classify them by angles and by sides. Notice here, this is a classification by side. By side, by side. These are all classifications by angles. So we'll always classify our triangles 2 different ways. Yeah?
Can a right triangle be a scaling triangle?
A right triangle can be scaling, yeah. It can also be isosceles. Yeah. Can it be obtuse? No. No, it can only be one of those 3. Okay? All right. Well, here you go. Just to kind of summarize as I'm handing out your assignments today. Classifying triangles. You can classify them by sides and by angles. Read through that. Copy down what you need to there. Okay? Hold on one second. Okay, let's take a look at this. Classifying triangles real quick. Hey, big piece here. Make sure you put the markings. Okay, when we're classifying by side, equilateral, mean all sides are equal. Put your markings. Isosceles, at least 2 sides are equal. Put your markings. Scalene, no sides are equal. And I would like you to even put markings on that one. Okay? Equiangular, all angles congruent. Acute has 2, or all 3 angles are acute. A right has 1 right angle, and obtuse has 1 obtuse angle. 1 angle greater than 90. So you could have a isosceles right triangle. You can have a scalene obtuse triangle, a scalene right triangle, an equilateral equiangular triangle. Okay, that's also acute. All right. Your assignment today, well, first, any questions on that? I think we hit that pretty well. Okay, your assignment today is going to be both sides to draw on the paper. do your calculations, look for different triangles. There's a triangle right there, right? That's 15 and 62. Okay, and you guys look at that, hey, that's 77. And then I know that 77 plus x has to equal 180. So x equals whatever. Okay? Don't be afraid to draw on it. Note that you have triangles now. You also have straight lines. Once you know x, you also know y. And if you look at y, y is a remote exterior angle. It means it's exactly the same as those two added up. Does everyone see that? Remember the theorem we talked about? If I were to take that triangle out of there, we talked about it at the beginning of the lesson today. This angle right here is that one plus that one added up. Okay, well those two angles are the 62 and 15. This one is angle y. So if I add up 62 and 15, I already know that it's 77. The other way you could do it is you could find x and say x plus y is 180 degrees. Okay, so look for the different triangles. All right? Let me know if you need help, please. I'll be coming around helping out. Here, just really quick.
Yes.
So if you have earbuds in, they need to come out right now. So just so that we're clear, you guys, you can use remote exterior, your remote interior angles, excuse me, to find that angle. You can also just look at this and find W by focusing. If I'm dealing with this triangle, I could just focus in right there with the 32 and 48 and W have to add up to 180. And once I know, or excuse me, 32, 48 and U have to add up to 180. Anyone find U already on that one? What is it? 100 what? 100 degrees exactly. Is that right? Okay, so I got a second there. All right, so if I know that's 100, I could then just look at U and W. Those two add up to, what does that add up to? 180. They just make a straight line. Okay, so you don't have to use these two to find that one. You could just use straight lines. And in math, there's a lot of times there's multiple ways to doing this, and that happens a lot in geometry. Here you can use those two angles, or you can just say this plus this has to be 180, therefore W has to be 80 degrees. And then once I know 80, 27, and V, that make up that triangle. And that adds up to 180. Okay? The other thing, just so that we're clear, on the other side, if you looked at 11, it says, Cameron pointed out, if the angles are the same, then the measurements better be the same. That means those two are congruent. Okay? And that's true with sides, angles, whatever. Okay? All right. Good questions. Keep asking them.